Hello, hello. So, let's start this talk with a preface or so. Imagine that there were such situations that you had your code written so perfectly, all the tests were written there, you know everything about what's going to happen with your script or your service, or whatever scope you're taking at this point. But sometimes it doesn't work that way. The reality is different. So, let's take a hypothetical situation. Let's say we have our hero, Buckswatter hero. He has embarked on an adventure to swat some bugs that doesn't let your service to work. He has entered some questionable debugging decisions, like adding prints to your code, or another questionable reasoning that you shouldn't probably do in your life, because the tracebacks already tell you what's going to happen. Or if you have entered such depths of using a PDB, which is a Python debugger, that you debug while the code is running, there are two questions. One, why would you use a Python debugger in prod? And two, using PDB is like pouring fuel in the fire. You're overloading yourself with more information that you don't need to, and probably learning PDB is harder than writing any kind of code you've ever written in your life. And God bless this Buckswatter's hero's soul if he enters the abyss that covers this kind of fish. This fish is very notorious in some old timers. And in reality, it's a GNU debugger. Don't do this, please. So how did our Buckswatter hero come to this place? Well, it's a consequence of having no observability whatsoever. So let me sell you on the idea of observability. Why is it good to have it? And why would it help our Buckswatter hero? One, it will make your decisions way easier. You will have numerics, logs, history, and so on to base your decisions more accurately and more faster. And less unhappy faces. The Buckswatter hero wouldn't be so angry. Your clients wouldn't be so angry, and everybody else that surrounds your program would be much more happier. Also, as well, it rationalizes whatever you do in your code. May it be some weird snippet of code that you have no idea how it works, but it works. Or if it's, well, how should I say? Such code that it's perfect, very, very readable, and so on. It just rationalizes. You know what's going to happen with that code. And lastly, you can make some sick graphs. Everybody likes graphs. Have I sold you on this idea? Then if yes, then join me in exploring how to keep your sanity with Python observability. I am, as was introduced, Martynas Saulius. I am a Python developer in Oxy Labs. And recent 1 to 2 years, yeah, I've been doing observability. So how can we get this observability done? Mainly, there are 3 concepts that we can talk about. One of those concepts, well, basically there are a lot of them, but most of the sources would determine 3 main ones. First one is tracing. The second one is logs. And the third one are metrics. So all these 3 concepts generate what is the observability triangle. So let's talk about them, starting with logs. So what's a log? Basically, it's just a record of what your system has done somewhere in the time in the past. It just did something, told the computer, yeah, I did this, and outputted it somewhere. Usually, logs take the format of having a timestamp, a log level, and a message. It's very loosely based because anything can be a log if you think about it hard enough. But generally, you want to know when it happened, what severity was the event, and what just happened. That's it. Oh, by the way, those who have keen eyes, there are log messages in every slide. Good luck. So what would you like to log? I probably skipped one in the top, but let's just talk normally. So first of all, you want to know when your service started, or your script started, or whatever thing started. Let's just say you have a long-running service. It gets a request. Bam, you want to know what happened. Stamp it. At this time, we got a request. The second thing you want to log is when the service exits, when the request just ended, and you want to say, why it happened, with what result it happened, and how long it took. Thirdly, what you want to log is having branching choices. If there's a single if in your code, you log it. If there's a single factory, you log it. You want to know what made your outcome to be like that. And lastly is external calls, which is more technical than that. Just if your request needs to go into the internet, to the database or memcache, whatever, anything that isn't your service, you want to log it as well. There's another thing that you can log. It's called everything. But there are some caveats with that everything. So now that we know what we can log, this is some sample log thing. This is Sanic. Sanic is a HTTP API, a synchronous one. I'm not going to talk about what it does. It generally listens on certain endpoints, and you can do whatever you want with those endpoints. So you can see that the Sanic log that it started, and every time it got a request, it just outputted what endpoint was reached and what was the outcome of that. The last one, send help, is actually send help. I didn't think of any endpoints to show. So there are some ways of reaching those logs. The first one is prints. Yes, the same one prints that our Buckswatter hero went and added to their code for whatever reason. So the same code segment can be looked like this. You have your code, it does something, you print out into standard output something. We got a log. It's a history. Something happened. But this does not look like a log that I've loosely told before, right? So we can make a very convoluted print method that formats the print output and adds some nitty-gritty things like datetime, some other nitty-gritty things like you can add the arguments and so on. If you ever have to do this, why? Seriously, don't. So there are two problems with using prints as logs. You can use them if your scope is like small script. Make it beautiful, make it for one use only. But one, you cannot turn off your prints. If you added them to your code, they will always output, no matter what. And the second of all is you need to choose where to output it. You can output it to standard output, to files, to error streams, and so on. But for each one, you need to add an argument for the print, which means if you're going this kind of method of using prints, you'll have to use a lot of print methods, which is cumbersome. If it's bad, is there another solution? Why, yes, there is. Praise logging. Yes, let's praise it all. It's one of my favorite modules in Python that isn't built. You can use it whenever, however, in many different ways. So what could make it better than prints? First of all, you can actually set your logger to log out certain levels of logs. Usually there are preset determined ones like critical error, warning, info, debug, and not set. And you can add certain levels of your logging. Remember how I said everything? You can log everything as debug and not output it. It's still going to be in code. It's going to tell you what's going to happen, but you don't need to see it right now. Secondly, you can format each message to have in any way, shape, or form you want. And you do not need to add those things yourself. You can use logging's inbuilt templating variables to add anything you want. Datetime, from which file it happened, what line it happened. It's great. And thirdly, it's a bit more complex. Plus, yeah, about that. So this is basically showing that you can make your own logger from using the logging module. You can customize each of those loggers to output to as many output targets you want, which is file, output, standard output, any RabbitMQ shenanigans, and so on. And you can add different formatting systems, and you can do that with different levels as well. Some you want to see all the debugs, just output the file. You want to see only the things that happen in your program, you can output the standard output. Customizable as hell. Great. So, praise logging. So how we use those logs in general? As I said, it really depends on your scope. If it's just a regular file, just standard outputting that is just fine and dandy. You can see what's happened. If you have a remote solution like server or having a long-running one, you cannot be looking at screen all the time, can you? Yeah, I thought so. So you can upload it just to the file, have a log of history, what your program did. Otherwise, there are some shenanigans called Graylog and Elasticsearch, Logstash, and Kibana Stack. Those are log management systems that you can output your structured logs, and you can aggregate them, question mark. Those things do stuff. What? It's another topic for another talk. But you can just output them and have the management done. If your scope is like having multiple servers that output into files, and you don't want to scour all of them. Logs are cool, right? But they come with some caveats. The first problem that we can talk is that there's a performance overhead. You're working with strings. If you need that 1 millisecond, nanosecond, or what, it's pretty bad. It really impairs everything what you do. So you have to be careful when logging very crucial, essential places. Second of all is that too much is too bad. The more logs you have, the more you populate your history, the worse it is to read through all of that. Who likes reading a lot in very short span of times? Nobody. Unless anybody wants to raise hands. I'll judge you. Gotcha. Perfect. Later. So, third one is the scalability problems. The more you add servers and that log out, and you need to have them ingested by some log management applications, sure, you can add Elasticsearch and it'll do fine with, let's say, 100 to 1,000 logs per second. But what happens if you have 2,000 logs per second? It will choke and die. So to not lose any data that you send to your Elasticsearch, you need to add certain brokers like Rabbit or Kafka, and those are jumble words that most of you probably know. So that's that. And lastly, logs aren't really meant to be aggregated. The thing is that log, in general, is a human-readable thing. So if you need to have analysis of logs, you'd need to read through all of that as well, which really sucks if you need something more analytical, like using maps or imagination is the ceiling. So those are the cons. Luckily, observability has a solution to this. Let's come in with metrics. This is my probably most favorite thing of all observability-free things, and probably I know the most of, but if I'm going to talk about everything, you will not leave this building. So, what is a metric? It's basically the same as a log, but in general, it has only very few things that makes it. First of all, it has a string identifier that uniquely identifies what kind of metric or event is happening. And secondly, it has a label that just differentiates that metric by some caveat or status or so on. Sure, and lastly, it has a value. Metrics have values, while logs you don't really need to. It's optional. That's a very good plus for metrics. You can see there's a metric example here. This is very akin to how Prometheus shows its metrics. So going aside from that is that we are going to talk why would you want to pay over logs, which I probably already touched on them before, but I cannot really feel the passage of time, is that, first of all, they are storage efficient. As I said, it has only numbers. It has a certain amount of strings, and they usually repeat each other. So that means whenever you send out the metric, those who will aggregate those metrics, they do not need a lot of space. So you can have up to 10 years of information if you're doing this correctly. Second of all, it's easy to query. Because they're lightweight, you can use them to query and create those sick graphs that I've shown before. And you can have alerts, which are useful, kind of. So let's talk what kind of metrics are there. There are three types in general. First, well, three mostly used kind of metrics. I'll just loosely say this. because most of the metric systems use their own lingo and systems, how they save those metrics. So I'm just going to touch on the three ones that are usually the most common ones. First one is the counter. The counter is pretty simple. Count up, count down. Something happened, count up. Something didn't happen, count down. Pretty simple, right? Second one is, I'm jumping ahead of my time, and I think I just induced some nightmares for some people. Gauge is very simple. It has one set number. It can move up or down arbitrarily, but it's mostly used to show some constant number or long sitting number. Most uses are checking how many connections there are to your service, or what's the temperature of your room. That's a gauge. Lastly is, I am not going to do a mathematical lecture here, but I'll just say this jumble of words and you'll take out whatever you want. A histogram basically measures the frequency of your data values and puts them into buckets that are split by intervals. Jumble of words, it's a cool thing. Check it out later on because it's a bit more statistical than I just said. So, how we can gather those metrics in Python. The first way is push metrics. This is statsd. It's a Node.js collector that sits on Graphite, and it basically aggregates all the metrics that is sent to him. What happens that service, whenever something happens that he wants to count, he shoots an UDP packet, and whenever collector gets it, he says, OK, I got it on this interval. I'll just aggregate it and put it in my database. Simple. The second one is what I personally use the most, is Prometheus. It's the pull metrics method, where instead of the service sending the metrics, Prometheus regularly asks an endpoint that is sitting on the service that, please return me a simple text format metrics. The difference between these two and why would you want to use both of them is depending on your case. The push metrics are great if you have a script or something that does not stay for long, because pull metrics require a long-running service, and it requires to have an HTTP engine, which is heretical sometimes, to ask for metrics. There is a solution for pushing metrics with Prometheus. I do not really recommend it, personally. So, implementing in code. So this code is very simple. It just randomizes numbers from 0 to 5. If the number is less than 2, we mark it as good. If it's more, we mark it as bad. So with statsd, you just say where you need to shoot the metrics. And every time there's an event, it will use the foo as an identifier. And everything that comes after dots, you can have layers of identifications. This is the statsd way of having labels in this. With Prometheus, it's a bit different. In Prometheus, you need to have your service to have defined metrics, and you'll need to access those metrics and tell them, yeah, you're going to do this, you're going to have this number, and I'm going to aggregate you over time at my own pace. Prometheus just gets the information which is totally saved. Like, that is the output that metrics usually outputs, and this is after leaving for 20 minutes. I think. 20 minutes? No, that's less. I think I've rushed that work. But it always gets an increasing counter, and it saves that increasing counter in Prometheus, and you just query them in some shape or way. There are a lot of methods, and that's talk for another time. So how can we use those metrics? Generally, it's used in analytical and reactive things, which translates loosely into graphs and alerts. With graphs, you can have those collectors be queried by certain things like Grafana, or if you have very good imagination, and I'd like to hear you how, query the information yourselves and draw whatever shenanigans you want. That's a very artistic thing that you can do. But I generally recommend Grafana. It's very simple to implement into anywhere, and generally doesn't require a lot of knowledge. Now, the second thing is that with alerting, whenever something bad happens, or you can see from the metrics, just jobs are too slow, or we're having a lot of errors and so on, what do you do? I don't know how to do alerting with statsd because it was so complicated. My head hurt after reading the solutions that people were giving. That requires a third middleman and so on. I'll just give a more simpler way of how the alerts are being generally used now. So there is a thing in Prometheus called Alert Manager. It's a part of its stack. And whenever it hits a rule, which is the expression of the metric, it will trigger every receiver that was predetermined or configured. The receiver can be email, some sort of webhook, Slack, and our recent things that is giving me nightmares sometimes. It triggers one specific point. It has a config for that. It's called PagerDuty. PagerDuty is just a configurable service that can call your phone, even at night. I hate it and I love it. So, now that we have all those metrics and so on, they still have their cons. Everything has their own cons, even if I just told you that it's one of the most amazing things you can have. First of all is that you lose the minute details. If you need to know what exactly transpired at that moment, metrics don't tell that. They only count. They have no idea what's the context and why they had that context. You can have a general idea with the metric what's happening, but not the exact one. And secondly, oh, whoa, too much. With metrics, you can only basically see the system-wide performance. You can see what happened where. Like, let's say database just said, oh, I'm going to be very hogging on you and will be slow because I have a bad day. Or other reasonings in their service if they have multiple parts. But you cannot basically pinpoint why the request ended at 500 or why the request said, I'm not going to take 2 seconds, I'm going to take 20 minutes. That is how you use metrics, but you cannot really say why that 20-minute happened. Luckily, this can be solved by tracing. Coincidence, right? Tracing. Basically, it's a very loosely added logs together that usually have some link between each other. Most of the cases that you can find have a certain trace ID that determines all the log messages belonging to that one request. With that, you can have a full vision how the request entered the system, through what components it went, and how it exited. You can have their latency, you can have their status, you can have their all minute details why that request happened with what variables and so on. All the context is there, and you can have all the requests done all just fine. Generally, the tracing looks like this. How would you visualize it in general? Let's say that you have a request that done to the point A. But point A has another, it cannot really do everything that your request does, so it delegates the further request to B. And so on. You can see the graph just fine, I guess, unless raise the hands who can't see it. Perfect. So with this, you can see how, through the logs that trace ID, that with entry and output shenanigans, you can see how long one or another took time to, how long it took from one service to go to another service. With using this knowledge, you can build a graph that looks like spans. Spans are basically scopes of your job, and how deep your request went and how long it took. Using these spans, you can find many solutions to general ideas like find the bottleneck, everybody's most favorite game. Or you can find points that were very unneeded or took too long and so on. Now, how can we instrument this in Python or in general, basically? So ways to instrument it is, first one, it's manually. Whenever a request comes to your system, you can add a trace ID, like an UUD4 number or string, and send it throughout the whole system. Every time the log happens, it sees that there's a trace ID given, and it will log the trace ID with them. Most basic way of implementing if you want to implement it. The second one is the easiest way, question mark, Because the black box method is such a method that it requires no instrumentation whatsoever. You have all those logs in your system. You just loosely correlate between the variables how the request went. There are two problems with this. One, you need to have lots of data points to understand how the request went. And secondly, you need different, you don't need, I'm sorry. You need to have such logs that do not have very changing variables. You need to have certain data points, how you discern it. If they start repeating between each other on different services, you can discern what's happened, but are you sure it's the same request? No, usually not. Last one is the most difficult one. There's a Google white paper about that. I've tried reading it, lost my mind. It's basically adding metadata to each log, and you can add as many things as you want into that log, such as its own trace ID, which was loosely touched on manual. You can add certain scope IDs, that how deep the trace is going, and whatever your heart says you want to know about your request. So there is another thing. I could loosely touch this, is that usually if you're doing tracing, it's basically the same logs, but with more information. More information means less data retainability. Less data retainability, you lose your history. So to counteract with tracing, tracing has such methods called sampling. Well, most observability tools have sampling, but it's mostly used with tracing. So you can choose what to trace by using these two methods. First method is the head method. It's usually decided at the head of the request, at the start, if this request is going to be traced. It's usually decided very arbitrarily, random. You throw the dice. 10% of requests will be traced. So you got 10% chance that you're going to get a trace ID on your request. Perfect. You got 10% of all your requests traced. You can have your average performance, and you can start bottleneck checking. All good. The second one is analytical. It's called tail-based sampling, which you use to determine if the trace is important for you. Usually it's done by, at the end of the request, at the tail. That's why it's tail. So with that, you use latency. The request took absurd amount of times, I want to save that. Or it took no time whatsoever, and that's very strange. Or there was an error, and so on. It sounds very great, but it requires more instrumentation and logic to your application, which, yeah. So, how do we instrument it into Python? Here comes OpenTelemetry to future, which I am not going to talk about the code. To write a decent example for OpenTelemetry takes a bit more than just snippets of code, because you need to understand a lot of underlying terminology and how it works. But basic idea is that you can create traces and spans being scopes, as context managers in your code, which whenever they enter, they start monitoring that span. When the job is done, it sends the span to OpenTelemetry, which acts only as a collector, a standardized collector. And then you can just send all that data to Jagger or Zipkin to investigate what the hell happened with your code. And that's about it. So traces are cool and all, but there are some difficulties right now. They're alleviated over time, but some still remain. First one is that not all services are, well, capable of tracing. There are some databases or memcaches that if you send your request, you're not guaranteed to have a trace. And some say it's a good thing because you know it's an external call and you don't really need to know what happened inside there. Some say it's bad because if you're tracing everything. You want to know everything about your request to all the minute details that are in there. Second one is if you have a system that is not particularly designed to have tracing, you will need to work very hard to implement it. You'll need to start from the top and add each scope a trace logic. and it may require a lot of time, a lot of people, and a lot of coordination between your teams. So a headache in general. So here we go. That's all free observability tools. So let's return to our hero Buckswater. The Buckswater escaped the depths of questionable debugging. He has saw the terrors of the fishes and the terrors of having fuel in his hands for whatever reason. And he has found the trifecta of observability: the logbook of history, the metric map, and the guiding fairy of traces. Using the map and the fairy, he has discerned at which point the server was burning. Such an epic story, he knew that gas has to go there. The solution is there. He enters the hellfire, there are flames everywhere, the server is basically crying out of pain, but using the logbook of history, he knows where exactly he has to go. And using all these three tools, he has found the mother bug, which he swatted at the end and saw the daylight. Moral of the story: stop slacking on observability. Thank you. Are there any questions? Let's go.
Have you looked for alternatives to the standard library logging module?
Prints, basically. But there are some add-ons to the logging module, like struct log and so on. But I haven't seen, well, maybe not seen, maybe I haven't even put time, because learning logging module of whole takes a long time. So I haven't searched any alternatives. I've just grinded the same whole thing for a long time.
I recently read that it's like one of the oldest and the ugliest, most like Java-esque part of the standard library, and I kind of agree with it. And there should be alternatives, I think.
There are alternatives, but if it works, why do you need to switch
ugly,
it?
It's hard to use.
You can automate your logging, but I'm waiting to see those solutions.
No, just I'm writing something, I want to log messages, and I want some flexibility so that I don't need to do just this, I don't know, kind of snippets of Java to direct some of the logging to, I don't know, direct the logging from a certain part of the system to a file. Just.
I understand that basically with logging, it may cause some issues how your code looks. It does impede a lot of space. But if you need to tell what your system did, you either need to hide it very effectively, which I have no idea how can you hide strings in your code. Maybe with very underlying in the functions, you can have those decorators like, please log this, because this was the method that acted on that, and it returns such a result. You can use very elaborate hiding methods. But with outputting, I cannot really think of anything that could change logging right now. And I'd like to see some alternatives. Logging is really great, but that's a good point. That logging, as much as you can praise it, it may be disgusting if you want to learn the underlying things. Anything else?
Let's say you have
I see
a certain amount of tests on your script or your API.
Yes.
That cover basically everything. How do you determine which essential parts are to be logged? Not thinking about how to catch the bug logged as you have already. Let's say you write the TDD, right? So
Yes.
everything. How do you determine which parts are essential?
Well, I've talked about in this talk about those 4 points that you want to: entry, exit, branching points, and external calls, right? But there was the 5th point there was with a reason. You want everything to be logged, every action that your program does. And even if you have all the tests done and you covered your code, it does not cover all the situations that your tests do cover. There are always some catch or an edge case that you can't really find or didn't think of it until it went to the prod. So if you have logs that log everything, Just switch from info to debug, and you can work with it. I knew that there were 3 hands in that side, so let's start with the closest one. Yes.
You mentioned that the rule of thumb is to add logging to the conditional statements in the function, right?
Yes, those that determine the outcome, yes.
Yeah. Very interesting idea, but what do you log in this case? The fact that it's in this branch, or the exact data which caused the expression, you know? Like, let's say the conditional statement says if this times this equals is more than this, right?
Mm-hmm.
Do you log all 3 of the data, or do you just log out and this branch was chosen?
If we're using the rule of thumb rule that you log only the branching choices, and if you do not want to overcumber your logging, general idea is log the fact that it entered such a branch. If you need context, you can log the context next to it. It's your own choice. But generally, you want the fact that it was chosen like that or that. Whenever you need to debug, you will see that there was a branching choice. You will return to that point, and then you can check with that context using other tools, or if you had the variables added there, you can start debugging and why it happened. Does that cover what you wanted? Mm-hmm. Okay, 2 more hands I saw there. Mm-hmm. Parallelism. Well, statsd in general, from its logical standpoint, statsd just shoots an UDP packet. What?
Repeat the question. They didn't hear.
Oh, you didn't hear. The question was that are metric solutions support parallel multithreading situations? Yes. It depends on which solution you take. Generally, Prometheus, if you have a running HTTP engine running on a second thread, then Prometheus just can ask that endpoint and say, please give me your metrics. And that the only problem is the mutex part, that you need to have a lock and pick that. It has certain things straightened out, but there's sometimes deadlocks which kind of hurt. The recent deadlock that I had with Prometheus was that the garbage collector actually locked up the whole Prometheus shenanigan, and the whole program didn't work because locks. With statsd, it's a bit more simpler, because every time you shoot a metric, it just shoots an UDP packet and it forgets that it happened. If it's gonna reach the statsd collector, that's great. If it doesn't, well, tough luck. Does that answer? Cool. I see one there, and I should probably look like that.
Presentation. So my question consists of 2 parts. The first one being, would you agree or disagree that if you want to log a Python application and not the operating system or container where it's running, you would be more willing to look into push metrics and push approach metrics?
Really depends, because I personally, my own bias would be using the pull metrics, the Prometheus version of it. The push ones, I would only use them at cases where your Python environment does not run the whole time. Like a cron job and it runs a Python script. Yes, you can log that, but if you need metrics, it's easier to just push them out than to have the pull. And if you're going into the service, yeah, I'm personally going to use Prometheus more.
Okay, because my second part of the question is I'm the InfluxDB guy, not the Prometheus guy.
I understand your concerns.
I tried both, and I was freaked out by the approach that you can't insert a metric into Prometheus 5 minutes after the time has passed. And InfluxDB is, proper database as we know it.
It's
So,
at the time series based.
Do you have a stance on InfluxDB versus Prometheus debate?
My first debate and probably the main argument for Prometheus versus InfluxDB is that there are two different things in a sense, because InfluxDB is more designed to still have the event logs, but still have the aggregation power of the metrics. So you can use them as both if it takes the cake. While Prometheus, generally, if you're monitoring something, you want to know at the least possible resolution interval. Those 15 seconds are important. If you need to add metrics 5 minutes after the fact, why are you metricizing? It's basically adding logs that are 5 minutes later. So
That was the last question.
yes, that will be the last one. Probably. So I don't know. If you want, we can discuss later on, because I've used InfluxDB as well. I partially like it and dislike it because it has known caveats where I can use it. So that's that. Anyways, then.